Welcome to a geometric conjecture. Here's a story of the fine structure constant, and much else besides. We'll recall central trunks, branches, and zones in the toroidal surface of master maps, analogous to the blueprints of nature, wherein nature has the loveliest story to tell. We establish the weight of each knot by comparing its code to all 729 knots in the map. The nest weight is the sum of the 9 knots housed in that nest. These sums are registered in maps 1M, 2M, and 3M. If we now recalibrate each weight by comparing each code only to those 81 knots in the same trunk, then we establish the new nest weights depicted in maps 1T, 2B, and 3T, or 3B. Maps O simply register respective differences between maps M and T, or those between M and B. We discern weights in these various ways simply because that is how nature works, just as we see maps 1 and 2 simply decouple from map 3. We behold parity or symmetry breaking right before our eyes. We establish relative particle positions and properties in other videos. We also mention 2 pairs of parameters defining the fine structure constant, in accordance with James Gilson's work from Queen Mary University of London, whereby we corroborate his idea of quantizing the FSC with 137 and 29 or 128 and 31 sided polygons with nest weights to give these conjectured exact FSC values, differing from the recommended codata range by just the 12th place value. Viewers may wish to take a moment as we imagine the FSC mechanism as a node or puncture in the toroidal surface, from where the FSC metaphorically pulls the torus inside out. This breach in geometry is tantamount to a change in magnitude. Importantly, the breach is conditional to the FSC mediating between synonymous geometries. It cannot occur otherwise, which is precisely why nature is not chaotic, and precisely how and why it manifests at all. We'll interrupt to render the Z boson's relative mass of 59 and consider it to mediate between zone 1 and the other 2 zones. And we'll render the bifurcating W boson's relative mass of 52 in 2 ways. First, mediating within each of zone 2 and zone 3, and second, mediating between those 2 zones. Nature's W boson is a bifurcating champion. And we'll continue by conjoining the adjacent Z nests with the spin-up, spin-down particles in map 1T. 103 plus 2 lots of 17 is 137. And we'll render the 29 component like so, conditioning us to the complexities between the 3 bosons and between maps. In similar fashion, the adjacent W nests sum to 94 plus 2 lots of 17, with the 31 component rendering like so. Note here, however, that each 17 now corresponds to a different particle, in this case a down quark and an up quark, helping us understand why quarks only manifest in pairs. Remember that the description or the depiction of particles in these maps simply allows some sense of what is going on. In nature, particles don't reside in any particular place. They oscillate and entangle with one another synonymously, as only partially portrayed here. With that in mind, let us continue with the fundamental protagonists in nature's story, where attention is drawn to these relationships, being mindful of palindromic numbers, for that W boson functions to turn things around and inside out. By way of example, these relative masses bifurcate into mantissa and order of magnitude components, whereby we'll focus on the mantissa and deal with matters of magnitude elsewhere, where elsewhere turns out to be very close to home. Indeed, nature has a story to tell. In preparation for what is to come, we'll return to the adjacent Z nests in map 1M, T, and O, and sum their weights as 103, 45, and 58. If we now allocate each central nest a weight of 9, the corresponding sums are 81, 37, 53. Allocating each a weight of 1 gives 73, 29, 45. In similar fashion, W nests sum to 94, 45, and 49, and allocating central nests a weight of 9 gives 75, 37, 47, and allocating each a weight of 1 gives us 67, 29, 39. Note that these adjacent nest weights are indistinguishable, allowing us to breach into either zone. Likewise when summing vertical adjacent nests. There are untold relationships to consider. However, much of the complexity associated with particle and FSC entanglement can be seen in these maps. It is important to note that every particle is accounted for in the red circled regions, and we'll speculate that there is no shortfall nor surplus of nest weight utility here, for it is safe to assume that nature utilizes all relationships in some way. We'll surmise with less significance on the trivial. And a full nest necessitates a breach and the potential to combine nest weights with that from some other breach to manifest a particle, whereby the governing FSC ensures everything be maximally synonymous or non-trivial. Watch now as we morph from maps 1M, T, and O into maps 2M, B, and O, where red circled nests remain fixed relative to our vantage, helping us to disentangle the entanglement. And watch as we morph into maps 3M, T, and OT, noting some other manifestations. And morphing into maps 3MB and OB, we continue to notice synonymous patterns of behavior. Fathoming the kaleidoscopic symmetry within master maps demands humility. Suffice to say, a wide audience is required to critique and ponder it all. All possible interactions are likely entangled in these blueprints, manifesting for greatest global equanimity. Therein begs the question of interest. Such is the outrageous majesty of nature, each to fathom in their own way.